Good evening, my name is Rob Olson. I am the controls chief engineer for this year's car. I'm also in charge of the electronics, the shifter, and the braking systems. To my right is Rico Santos, he's in charge of the clutch and the control. Okay, to start off, our department goals haven't changed since CDR. They are to utilize the advanced features of the Motec ECU to full advantages, organize and have a plan of attack for the wiring inside the car, and shorten manufacturing time by maintaining previous designs as much as possible. So the components of the electronics consist of the gate acquisition, the driver display, the ECU, ignition, battery, and shifting and braking electronics. So to start, we'll talk about the Motec SDL driver display and gate acquisition. It is an all-in-one unit that serves as a display, a logger, and a controller. The display functions display on the digital display RPMs, oil coolant temperatures, and shift locations. The data logging functions allow for multiple gate acquisition inputs for such things as lateral longitude acceleration, linear position of the shocks, or fuel level gauge, and that information can be inputted into the internal 8 megabyte data logging memory of the SDL unit, and this can all be downloaded into the computer and analyzed by the data analysis software given by Motec. And the third function of the Motec is a controller function, which you can program up to 20 user-defined alarms for such things as if the coolant gets too hot, you can set it to a specific temperature, and the display will let you know if you're reaching that temperature or not. And it also features digital and switched outputs for such things as shift lights, warning lights, or fans from associated to additives. The ECU unit we're using this year is again the Motec M4 unit. It has multiple sensor inputs for pressure, temperature, and advanced functions for the digital speed inputs for such things as wheel speed sensors and the Hall effect sensors. And these are used for such things as the traction control launch features of Motec and the gear change ignition cut when you switch gears. There's also wideband landing cable. And the outputs consist of the 4 injector outputs, the ignition output, and 4 auxiliary outputs for such things as fuel pump, idle speed control, etc. And the Motec ECU costs around $1,000. So the ignition we're using is again this year for the M&W Pro 12 ignition, same as last year. So capacitive discharge type ignition, which eliminates the 10,000 RPM limit of an inductive type ignition setup. It's very highly compatible with Motec ECU and retails for around $670. The batteries is a PowerMax battery, weighs about 2.8 pounds. Again, the same battery as last year. It retails for about $33 and has 56 cold peak amps. And the electronics in the braking system include the brake light, which by the FSA rules has to have a minimum of 15 watts, the brake light switch, and the brake pedal over travel switch, which is used for in case brake pedal loses hydraulic pressure and it goes beyond its specified limit as far as travel goes. The switch will engage and kill the power of the motor and stop the car. And the shifter system electronics consist of the paddle flap switches for the change gears up and down, and the Hall effect sensors for the gear change ignition cut. So as you can see, the total cost for the electronics are roughly around $2,900, which with most of the cost being ECU. And again, the highlights of the electronics are the tunable ECU and the ability for data acquisition and the digital heads-up display. I'm also in charge of the shifting system for this year's car. The components for the shifting system include the CO2 bottle, we're using a 9-ounce bottle, the pressure regulator, the air cylinder, the solenoid valves, and the associated hoses and fittings for that, and also the steering wheel bracket and carbon fiber blocks. So for the first half of the system, you have going from left to right, you have the steering wheel, then you have the bracket, the shifter bracket with the switches mounted on that, and then you have the carbon fiber flaps, and then you have the quick release disconnect for the actual steering wheel. And we're going to, again, from the 07 car, we're going to utilize the connector pin inserted inside the quick release, so to eliminate the wire going from the steering wheel into the dash. So a brief overview of the requirements. Given by Yamaha, we have to have a minimum of 30-pound force to shift gears with an angular displacement of 15.4 degrees. the actual force applied by the system is 110 pounds, and roughly about a 2.1 second response time. For the bottle we're using, again, we're using a 9-ounce bottle. When it's filled, it has roughly 32% CO2 liquid at a pressure of 125 psi. And if the actual bottle is at a temperature of roughly 77 degrees, we'll get around 588 shifts out of one bottle. And the change of mass from an empty, full and empty bottle is around 1.187 seconds. So some cosmos analysis done on the bracket and the lever arm. The bracket is made out of 6061 aluminum and has factor safety of 1.9. The lever arm is made out of 41 grade steel and has factor safety of 1.4. So the total cost for this system is roughly about $185. I'm also in charge of the brake system for this Series 5. And the deceleration required is 1.5 Gs. And through a study done by last year's brake engineer, a comfortable foot applied force for a non-professional racer, an average race car driver, is around 40.5 pounds. And through the brake Excel model that I was using, the front brake torque is around 3,300 pounds, the rear brake torque is around 1,400 pounds. And as you can see, the change in temperature from going from 80 miles an hour to complete stop for the front motors is around 370 degrees Fahrenheit. The rear is around 200 degrees. So again, for this year's car, we're going to be using steel full floating rotors. They're drilled in chamfered and machined in-house. Again, we'll be using the PS1, Wilwood PS1 brake calipers. They're a 2-piston fixed design with a front bore of 1.12 bore of 1.